Okay, here is the addition rule and complements. We're going to use addition rule for disjoint events. What that means when we have nothing in common between these two events, we call that disjoint events. So two events are disjoint if they have no outcomes in common. Another name of a disjoint event is mutually exclusive. In other words, two events are disjoint if they cannot occur at the same time. So see here in between of these two we have nothing in common. And the rule is, addition rule for these two events when we have nothing in common is probability of A or F is equal to probability of each one. So adding probability of each one individually. Let's have example for this part. For example, here in this event, I want to have sample space and numbers from 1 to 10. Let's use that. Then for this event, I'm going to use even numbers. And here, odd. So for even, we have, using this sample space of 1 to 10, we have 2, 4, 6, 8, 10. And here for odd, we have 1, 3, 5, 7, 9. As you can see here, between A and B, we have nothing in common. So we're going to show that with this, probability of A intersection B is empty set. Okay, so in general, we have, this is exactly what they have here. E, probability of E, union F. So when we have OR, that means that we have union in between. And that is equal to probability of E plus probability of F minus probability of E intersection F. In this case, since we have disjoint event, this one is empty set. That's why we have nothing on this part. If I wanted to write this one in words using and or in between instead of union intersection, when you have when you have union, we have or, and when you have intersection, this is and. What that means, if I wanted to write that part here, here is minus probability E and F. Once again, this one is empty set. That's why we don't have that part on this one here. Okay, and the addition rule for disjoint events can be extended to more than 2 disjoint events. I can have probability of E or F or G and so on. So this or means union. We can write E union F union G union is equal to probability of each one So writing each one individually, and we should add. So when you have or in between, meaning that you should add probability of each event. and so on. Now example 1, standard deck of cards contains 52 cards. Here we have 52 cards. This is what they have here. One card is randomly selected from the deck. Compute part A. Compute the probability of randomly selected a heart and or. Okay, here in between we have or. And here is claw from deck of cards. So we should find probability of heart or. So in between we have or, exactly same as the previous part here. That is equal to probability having heart plus probability of having claw. So here how many hearts we have is 13. Same thing for how many clubs we have, 13. And the number of outcomes in total, how many cards we have here is, it's given is 52 cards. Okay, now adding these two, we have 26 divided by 52. Simplify. The answer is 0.5. Now part B, compute the probability of randomly selecting heart or club or diamond. Again, here we have or in between. But we have 3 events. Exactly same as previous part. Now instead of having 2, we have 3. So that is equal to finding each one individually. Add them. Now how many hearts we have here in this part? We have 13 in total. How many cards we have? 52. Again, how many clubs we have? 13. Total 52. And how many diamonds we have? Again is 13. So from each group we have 13 cards. And adding, we have 39 divided by 52. Simplify. The answer is 0.75. Now number 2. The following probability model shows the distribution of murders by type of weapon for murder cases in 2009. Part A, verify that this is a probability model. What that means, each one of these probabilities should be between 0 and 1, and adding all these, we should have this part equal to 1. Obviously, all these numbers, each one of these are between 0 and 1. And if you try to add these, the answer will be equal to 1. So adding all these numbers, we have 1. So the answer is yes. And that is because we have probability model, and that is because all probabilities are between 0 and 1, and add up to 1. Now, part B, what is the probability that a randomly selected murder results from a rifle or shotgun? Okay, here is rifle and here is shotgun. And in between we have or. So exactly same as previous example. Now we have probability of rifle or shotgun, that is equal to so here for rifle we have 0.026. And for this part 0.031. So add these, the answer is 0.057. And it's asking to interpret this probability. Okay, so we have this number. Okay, I'm writing this one on top. We have 0.057. That is equal to 57 divided by 1000. What that means, if (1,000) murders were randomly selected, we expect 57 to be committed by rifle or shotgun, because here we have 57 on top. Okay, so it's same thing for all of these. I will not interpret the rest of this exactly same thing. So let's not use that one here. So for all of these we have same method to write what the output is. So exactly using this fraction instead of decimal number, use fraction and then write exactly what we had here. So denominator was total number of murders and 57 was what they use. Here in this case we had rifle shotgun. here is what is the probability that a randomly selected murder resulted from handgun, rifle, or shotgun. So here we have 3 events on this board. And between we have or again. Or rifle or shotgun. So that is equal to, you don't need to write all these, you can directly write what the probability is for each one. So first here I have that handgun, so let's use that one first. Okay, so this is equal to, for handgun we have 0.473. So we have these 3. For rifle is 0.026. And here is 0.031. So the answer is 0.403. So if you want to interpret like that, now instead of 57 we have 530 and denominator again 1000. So we only need to change these. So if 1000 murders were randomly selected, we expect 530 to be committed by these 3: handgun, rifle, shotgun. So exactly same thing. Now what is the probability that a randomly selected murder resulted from a weapon other than? So here is other than a gun. How we can find that is probability of other than gun is equal to 1 minus probability of gun was used. That is equal to 1 minus. What this means, gun was used. Here we have these 4. So that is probability of handgun or rifle or shotgun or unknown firearm. So this is, let's write that here. So what that is, probability of gun was used. This one is probability of all these: handgun or rifle or that's why for each one I should add the probability of each one. So So it's like this. Instead of writing that part here, I just summarize this one. Totally right. Probability of GAN was used. Adding all these four numbers and subtract from 1 is the answer for weapon other than gun. We have 0.473, that one. Third one is 0.31, and finally 0.141. Add all these, subtract from 1. The answer is 0.329. So this is the answer for part D. Next part, are murders with the shotgun unusual? Remember, for unusual, you should have probability less than 5%. So probability of, here asking for shotgun. And based on this table, we have 0.031. So compare this one with 5%. This is obviously less than 5%. That's why, yes, this one is unusual. Okay, we completed this part. Okay, I already covered this on the first page, but I mentioned that this part was equal to 0 or equal to empty set because we had two events that were disjoint, but here we have something in common between two events. So for any two events E and F, now we have this addition rule, and here in this case we have something in common. That's why we should subtract this intersection part to find the answer for union. Now example number 3, standard deck of cards contains 52 cards. One card is randomly selected from the deck. Part A, compute the probability of randomly selecting in 2 or, here we have 2 or heart. Okay, I'm gonna rewrite that part again, and because I did same thing on first page, showing with what OR and is. So here OR is union. And here and is intersection. Okay, so here on this part, finding probability of 2 or hard. Okay, let's go back here. Now here we have hard, and how many of that we have? We have 13, and here is 2. See, we have something in common. We have hard, and also that is 2. So that's why here we have intersection between these two events. So probability of 2 plus probability hard. And after that, you should subtract probability 2 and hard. So that is equal to how many 2 we have? We have 4. And total number of cards is 52 plus how many hearts we have? 13. Again, we have 52 cards minus. And the only one that we have both heart and 2, see, this is only one card here. So we have 1 having both of these evens. So it's 1 over 52 again. Add, subtract is 4 divided by 13. Rounding is 0.308. Now part B, computer probability of randomly selecting an ace or club. So exactly same as that one. We have something in common. Again, adding each one. And then subtract what we have in common. Ace and club. So how many aces we have is 4 divided by 52 plus how many clubs? Again, 13. And what we have in common between these two, we only have one card, that is club and also ace. That's 1 divided by 52. Exactly same answer. Again, 0.308. Okay, now example number 4. Consider the data in this table. We have this column male and second column females. Determine the probability that a randomly selected U.S. resident 15 years old or older is male. So finding probability of male. That is equal to number of males divided by total number of outcomes. Let's write total. So here we have for males. How many males we have? Here is 117.8. We should add all these to have 117.8. Let's work on all of these. For females, we have 124. So add all these numbers. It's equal to 124.4. And we need to know how many is in denominator. So what is a number of outcomes total? Males plus females is equal to 242.2. So this is total. So here on top we have 117.8 and denominator total is 242.2. And the answer is 0.486. Now part B, determine the probability that a random selected US resident is widow. So we have this part. And for that part we have 3. And here we have 11.4. So we should add these two. And in total we have 14.4. So this total was for number of outcomes. In part A. And now here is what we have total in denominator. So part B for this group. For male, we have 3. And for female, we have 11.4. So add these two. We have 14.4. Now finding the answer. Okay, so in total here on top, number of widows we have 14.4. And number of outcomes total here we had 242.2. So in total, how many we have here in this table? Is 242.2. Simplify, the answer is 0.059. Now, part C, determine the probability that the random selected US resident is widow or divorced. So we have or in between here on this part. So we have these two events, and we have or in between. Okay, is this one here and this one. So what we have are these two. I already have the data for the first part. So adding these two. Now for this part we have 23.8. So here we have 3 plus 11.4 and we got 14.4. And for divorce, here we have 10 plus 13.8. So that part is 23.8. Now writing the answer for this part, probability of in between we have or. Now add each one. And between these two events, we have nothing in common. So it's equal to here for total for that group, we have 14.4. And total, or in other words, number of outcomes. So we have 242.2 plus. Now in this group, here we have what we have after adding these two, we have 23.8. Number of outcomes, again, 242.2. And it's equal to 38.2 divided by denominator. That is 0.158. Now part D, determine the probability that a random selected is male or female. So obviously we have intersection between these two. Okay, so here is video and here is male. See, where is the point of intersection? Is this part. So the point that we have is this one, and the answer is 3. So we have 3 in common. F was female for this group. Okay, continue this straight line, and that is female. So the answer would be 11.4 is in common between this group and this group on top. And so the answer for this for probability of male or is equal to, add each one, so probability of each one first. Then if there was an intersection, we should subtract. So subtract intersection between these two. Once again, when we have intersection, there is and in between. When we have union, it's or in between. So here we have and. And number of outcomes was 242.2 for all of these. Now here sum for this column for males was 117.8. For this part video was sum was 14.4. And what we had in common here, the intersection between these two groups is 3. Add, subtract. On top we have 129.2. The answer is 0.533. Okay, now next part, compute the probability of an event using the complement rule. So suppose that the probability of an event E is known, and we would like to determine the probability that E doesn't occur. So that is what we need on this part. So complement of an event, let S, so S is again our sample space. So here this rectangle is our sample space. It's exactly the same as having universal Z. And let A be our event. Complement of A is showing with C on top. So that is, this C is complement. The complement of this event is all outcomes in the sample space S that are not outcomes in the event E. Well, let's have an example of what that is. So here this rectangle is our sample space. Here is our event E. Let's say here, here on this event E, for example, we have even numbers. And what they have here in this rectangle, we have all numbers, all natural numbers, for example. So all numbers that we have. And here on this part we have, which is complement of E, meaning that I'm not going to have the numbers that I have here inside the circle outside of that range. So on this part I have odd numbers. Here we have odd. So probability of complement of E is equal to 1 minus probability of E. And also here in this part, this is probability of our sample space, and that is equal to 1. So this one is probability of sample space. Okay, number 5. Golf ball is selected at random from a golf bag. If the golf bag contains 9 Titleist and 8 max flights and 3 top flights, find the probability of each event. Here again we have the first part, we have or in between. We have these 2 events and it's or. I'm using T for this part, M for that part. Probability of T or M. It's easy to write that way. So how many we have in that part? We have 9, and here for M we have 8. So for max flights we have 8. And before that we should know how many we have in total. So total number of outcomes is equal to 9 plus 8 plus 3, and that is equal to 20. So I used T, M, and here for this one let's use TF. So in total we have 20 is in denominator. Same thing for this one. And T is 9, M is 8. Okay, so here is the answer for part A. Now part B, the golf ball is not a Titleist, so probably that this is not T. That is equal to 1 minus probability of when we have T. So it's 1 minus. For T we have 9. In total we have 20. So the answer is 11 over 20, and it's 0.55. So here is not, that's why we subtracting from 1. Here again is not. So again we should subtract from 1. So probability of not, for this part we use TF. Again subtract from 1. Now here we have probability of top flight. Finding that, subtract from 1 is for when we don't have that part. It's 1 minus, for TF we have 3, in total 20. Number 6. Exclude leap years from the following calculation. Part A. Compute the probability that the random selected person doesn't have. So, does it have a birthday on November 8? Finding probability that it's not on November 8. Since we have not, again, I'm subtracting from 1. And here we have that is on November 8. 1 minus how many November 8s we have in a year? We only have one day, that is November 8. And in total, how many days we have in a year? 365. Okay, rounding it, that is the answer. Part B, compute the probability that the randomly selected person doesn't have a birthday on the first day of a month. Here again, does not. And it's on first day of month. Probability of not on first day. Again, we have does not, so subtract from 1. Since we have 12 months, and it's first day of month, we have here on top we have 12. And we have 365 days a year. So the answer is 0.967. Part C, compute the probability that a randomly selected person, again, doesn't have a birthday on their first day of month. Okay, now here we should count how many months we have it. 31 days. We have January, March, May, July, August, October, and December. Okay, so in total we have 7 months. Probability of not on the 31st day of month. So that is equal to 1 minus probability of on the 31st day. That's 1 minus. Here again, denominator is 365. And here in total we have 7 months. Okay, round that is 0.981. Part A, compute the probability that the randomly selected person was not born in December. Again, not. So it's not in December. You should subtract 1 minus probability, and it's on December. So it's in December. We have one minus how many days we have here in this month. In December we have 31 days. In total we have 365. We round that, the answer is 0.915. Okay, so I finished this part.